Hi guys, welcome to this next video. We're going to have a look at the last of these type of functions called rational functions. Guys, one thing I would point out, if you are having difficulty with some of the questions, make sure you do the following. Make sure that you, one, check your answer by differentiating it. So that should take you back to the original function. A number of guys I think aren't doing that, and in some of these video questions you're not getting the correct answers, and that either tells me that you're not quite understanding things, or you're working perhaps a little bit too quickly, may not be carefully enough. So if you are having trouble, one, check your answers. Secondly, make sure that you are asking the following day about things that you didn't quite understand, or email me about it as well. Okay guys, for this last video on rational functions, let's take a look at an example to begin with. One where I think we're going to be able to see pretty quickly that we can't employ other methods that we've used for previous rational functions. So a rational function is where you've got one thing essentially divided by another, which we do here. But it's not of those sort of ones where you've got a polynomial on top and bottom, where you could divide the bottom into the top, or write this over a simple single denominator and then integrate each part. Okay, instead we've got this weird looking trig thing. So how do we set about trying to integrate here? Well, unfortunately there's no sort of quotient rule for integration. So we have to go back to still employing the ideas about rational functions. Well, how do we do that here? Well, one thing I'd like you to appreciate is, once again, the work that we did earlier on differentiation of natural log functions. So let's say we had the natural log of some function of x, and let's take a simpler, let's take just a polynomial type of example. So let's say we had the natural log of x squared. Sorry guys, that's a bit messy. Let's tidy that up. Plus 7x. Now when you differentiate that, okay, we're going to get 1 over this function here times the derivative of what's inside, which in this case will be 2x plus 7. So if we put that together, we get the 2x plus 7 over x squared plus 7x. Yes, of course, plus c. Now one thing I'd really like you to concentrate on here and realize is that, okay, this here is a function of x, this part here. So this is what we're referring to over here. And that when you differentiated it, what we ended up with on the top there was the derivative of that function of x because of the process of differentiation. And here was that original fx part, the part that goes with the natural log. So what we've effectively got here is f dash x over fx. So I think it stands to reason then that if you are going to integrate this kind of situation where you've got a function of x and its derivative on top, it's going to take us back to this kind of situation. Okay, so what does that mean for this situation here? Well, if we're trying to integrate a situation where you've got a function of x on the bottom and its derivative on top, well, then it's going to take us to this answer. Okay, because if we derive this, so let's check again. If we derive this answer here, okay, we're going to get 1 over fx, because that's what you get when you derive the natural log part, and because of the chain rule, times the derivative of this part, which gives us f dash x. Put the two together, f dash x over fx. Okay, so in those situations then, where we have a function of x and its derivative on top, we've got one function, one part being divided by another, if we have that, then we can integrate to get back to this kind of solution. And if we look at this example here, what's the derivative of sine? Well, it's cosine, and the derivative of root 2 is 0. So this is a situation where we've got a function of x on the bottom and its derivative on top. So I can go straight to my solution saying, well, it's going to be the natural log, and yes, we do still need to take into account the absolute value. So let's add that in over there as well, of this function of x on the bottom plus c. Okay, so all good. What happens though if we have things which are slightly more complicated? Well, let's take a look at, say, something like the second example. Let's say we had the integral of, and we've got 6x on top, and we've got x squared plus 1 on the bottom. Well, if I look at that, I could possibly try and divide the bottom into the top, but that's getting messy. I don't think I'm going to be able to write that as over a common denominator. I mean, it doesn't work anyway. We've only got one term there, so that's just not an option. Okay, the only other thing to look at then is, okay, do I have a function on the bottom and its derivative on top? Not quite. If you look at the derivative of the bottom, it is 2x. So what I want is I want a 2x up there. And if I realize, well, 3 times 2x is equal to 6x, maybe if I put a constant of 3 out the front and rewrite that integral like that, the 3 times the 2x is the 6x, it's okay to take a constant out the front. Now we've got the situation of a function on the bottom and its derivative on top, so I can immediately write down the solution as being that, with the 3 in front. Okay, what about another example? Should we go to another page here? I think we will. And let's call this example 3. What happens if we had some sort of exponential function on the bottom? So let's put here e to the power of 3x, say plus 7, and the derivative of that would be e to the power of x times 3. So what happens if we had, say, something like 6e to the power of 3x there? Well, it's just mentioned a moment ago, if you have e to the power of 3x, if that was a function, or plus 7 of course, its derivative would be e to the power of 3x times 3 plus 0 when you derive that, so 3e to the power of 3x. Okay, this is 6 here, so what I need to do is I need to rewrite that top and take out a factor of 2, and then put the 3e to the power of 3x there on the bottom, our function of x still. Okay, and once again now we have this situation. We've got the derivative of this bottom function sitting on top, and so we can write down the answer immediately. Now it would be 2 times the integral natural log absolute value of that bottom function, plus c. Okay, what about a trig one? Let's have a look at, say, something like, let's take a look at question number 99 from your workbook. Something that looks a little daunting to begin with. Okay, so we've got 2 sec squared 2x over tan 2x. Okay, let's just check what is the derivative of tan 2x. Okay, so if we had y equals tan 2x, this derivative, well, the derivative of tan is sec squared, so it's going to be sec squared 2x and the chain rule times 2. So in fact we actually get immediately that top line, which is brilliant because it means I can write down the answer straight away. It's simply going to be the natural log absolute value of that bottom function. Okay, let's do one more example. Let's take a look at question number 106. Once again, another one that may look a little daunting to begin with. Right, we've got the sine of x minus pi over 4 on top, the cosine of x minus pi over 4 on the bottom. And if we look at that bottom function, if we derive that bottom function, well, the derivative of cosine is negative sine. So it's going to be negative sine of x minus pi over 4. Chain rule, so times the derivative of what's inside is simply just 1. So we've got a negative here. Okay, comparing that to the top, pretty similar, but I need a negative. So if I put a negative here, it means I've got to have a factor of negative 1 out the front to keep it equal. So a minus there, which is effectively negative 1 times that negative. Once again, we'll take you back to that positive. But I need the negative here, so to set it up so we have this situation again. Okay, so that's answer then. I can go straight to the answer. It's going to be negative from that negative in front. Natural log absolute value of that bottom function. Plus c. Okay, so what's the message here? Okay, if you have a situation where it's one function over another, okay, so we've got a function on the bottom and some other function on top, have a look to see if you can possibly arrange it so that this function at the top here is the derivative of this one. Some constant manipulation is sometimes needed to achieve that, but when you do achieve it, when you get this situation here, then you can write down the answer straight away as being natural log absolute value of that bottom function plus our constant. Okay guys, we'll leave it there. I'll be putting some questions once again into this. See if you can have a go, and don't forget to differentiate your answer as a check to see if it's correct.